Right now, ghost particles are passing through your body, trillions of them. They don't slow down, they don't bounce off you, they don't care that you're here. You've never felt one and you never will. But they're everywhere. So what are these ghost particles? They're called neutrinos. They're subatomic particles with almost no mass and no electric charge. That combination makes them extremely hard to stop. Light interacts with matter all the time. It bounces, scatters, gets absorbed. Neutrinos don't do that. A neutrino can pass straight through your body, through the earth beneath your feet, and keep going like nothing was there. Most of them never hit anything at all. That's why physicists call them ghost particles. So where do these neutrinos come from? The biggest source is actually the sun. Every second, nuclear reactions in its core produce vast numbers of neutrinos that stream straight out into space. They don't bounce around inside the sun like light does, they escape almost instantly. But most of the energetic neutrinos come from far more violent events. Exploding stars, supernovas so powerful they briefly outshine the entire galaxies. They're also created near black holes where matter falls in and heats up to extreme energies. Some of the neutrinos passed through you right now were created billions of years ago, long before Earth existed, long before the sun was formed. They've been traveling across the universe ever since, and you just happen to be in the way. So why are neutrinos so hard to detect? It comes down to how they interact with the universe. Neutrinos have almost no mass, they carry no electric charge, and they only interact through something called the weak nuclear force. That force is exactly what it sounds like. Weak. Most neutrinos pass through matter without ever touching a single atom. For perspective, a neutrino could pass through a wall of solid lead, 1 light-year thick, and still escape. That's why trillions of neutrinos pass through your body every second, and almost none of them ever leave a trace. They're not hiding, they're just ignoring everything. So how do you detect something that almost never interacts with matter? You make the detector massive. You hide it from everything else. Scientists build neutrino detectors deep underground, under mountains, or buried inside Arctic ice. The most famous one is called IceCube. It sits at the South Pole and uses a full cubic kilometer of solid ice as its detector. Thousands of light sensors are frozen deep into that ice, all waiting for something incredibly rare. Every so often, a neutrino actually hits an atom, and when that happens, it creates a tiny flash of blue light. IceCube catches that flash, and from it, scientists can work out the neutrino's direction and trace it back to where it came from in space. That's how we've linked neutrinos to exploding stars and violent regions near black holes. So why do neutrinos actually matter? Because light has limits. Light can be blocked by dust, by gas, even by gravity. Neutrinos don't have that problem. They pass straight out of places light can't escape from, like the cores of exploding stars and regions close to black holes. That means neutrinos let us study events we would otherwise never see. They give us information from inside stars, from the moment a supernova begins, and from the most extreme environments in the universe. They're not just strange particles, they're messengers. So what do we know? Right now, neutrinos are passing through you. They're moving through your eyes, your brain, and your DNA. Trillions of them every second. They don't hurt you, they don't leave a mark, most of them never interact with anything at all. They're just passing through, carrying information from stars that exploded billions of years ago. You can't feel them, you can't stop them, but they're here. That's a fact.